It is the most annoying accessory you own. You buy a sleek, extremely thin laptop that barely weighs anything, but to keep it working, you're forced to carry this thing. A heavy, bulky rectangular brick that gets hot, trips people over, and steals your space. But have you ever actually stopped to wonder why? Why is this massive chunk stuck right in the middle of your wire? Why can't we just have a normal, simple cord running straight from the wall to the computer, just like a lamp or a toaster? Welcome to the Blueprint Chronicles. Today, we are cracking open this plastic casing to look at the incredible engineering hidden right inside your charger. The answer lies inside this black box. It's not just a plug, it's a miniature power station, a translator, and a protective guard. To understand why it exists, we first have to look at the brutal reality of the electricity coming out of your wall. That power is chaotic. It's alternating current, or AC, meaning it violently flows back and forth, switching its direction 50 or 60 times every single second. On top of that, it packs a massive punch of high voltage, usually 110 or 220 volts. Think of it like a high-pressure fire hose. Meanwhile, your laptop's microchips are incredibly sensitive. They require a steady, calm, perfectly unidirectional flow called direct current, or DC, at a much lower voltage, usually around just 19 volts. If you plugged your laptop straight into the wall without this brick, that high-voltage AC would fry your motherboard instantly. To stop that from happening, this black box acts as a mediator, turning a raging river into a peaceful stream through 3 distinct engineering phases. The moment electricity enters the box, it slams into a component called a bridge rectifier. Think of it like 4 traffic officers standing at a chaotic intersection. No matter which direction the cars are coming from, they force every single one of them to turn and drive down the exact same one-way street. The bridge rectifier takes that wild, back-and-forth AC energy and flips the negative waves upward, creating a one-way path. But there's a catch. The resulting current is still incredibly unstable and constantly fluctuating. That jerky, pulsating power would destroy your computer's performance, which brings us to the largest component inside the box, the capacitor. You've probably seen these before. They look like tiny metal soda cans. The capacitor acts as an electrical water tank. When the incoming current surges high, the tank fills up and stores the excess. When the current drops, the tank instantly empties its stored energy to fill the gap. By constantly buffering the highs and lows, it smooths out the jagged pulses, turning them into a much more stable, level line of power. But the engineering challenge isn't over yet. Even though the power is now flowing in a straight line, the voltage is still dangerously high. In the past, dropping voltage down required massive, heavy iron coils. If modern tech still relied on those old methods, your laptop charger would literally weigh several kilograms. Instead, modern chargers use a brilliant, high-speed trick called a switched-mode power supply. Inside the box, a tiny transistor acts as an ultra-fast gatekeeper. It chops the high-voltage DC into microscopic pulses, turning on and off tens of thousands of times per second. By pushing the energy into these ultra-high-frequency pulses, the laws of physics allow us to use a remarkably tiny, lightweight transformer to effortlessly drop the voltage from a dangerous 220 volts down to the safe 19 volts your laptop actually needs. Finally, hidden deep inside the circuitry is a vital safety shield called an optocoupler. This is the ultimate guard. It creates a physical barrier separating the dangerous, high-voltage side of the charger from the low-voltage wire you touch with your hands. Because they can't physically touch, the optocoupler uses a microscopic beam of light to shoot data signals across the gap. If the voltage spikes too high on the wall side, the light beam immediately signals the transistor to slow down. This brilliant piece of optical isolation ensures that even if something catastrophically fails inside the charger, the dangerous current can never bridge the gap to shock you or destroy your device. So, the next time you trip over that bulky power brick, remember that it isn't just a useless piece of plastic. It is a highly complex, miniature city of bridges, reservoirs, and rapid-fire switches working tirelessly to keep your digital life running safely. If you loved uncovering the hidden blueprints of everyday tech, smash that like button and subscribe to the Blueprint Chronicles for more deep dives into the surprising mechanics of the world around us. See you in the next episode.